I am Dr.M.Murugalakshmi, Associate Professor of Chemistry, the Standard Fireworks Rajaratnam College for Women, Sivagasi. And in this video, you are going to see about the small topics, basic topics in organic chemistry, inductive and mesomeric effect. So first we will see the definition of the inductive effect. That is the movement of the sigma electrons towards the most electronegative element. That's called the inductive effect. Actually, we all heard of the bondings very well. The movement of sigma electrons towards the most electronegative element, which leads to polarization. The difference in electronegativity of the atoms linked together causes the inductive effect. If the electronegativities of the two atoms are differing, the link between them is automatically polarized. Suppose if you are having oxygen and hydrogen, say two dissimilar atoms, there will be a development of partial charges plus and minus depending upon their electronegativities at a relatively shorter distance, and this impact is no longer detectable after 4 bonds, and this causes a permanent dipole to arise in the molecule, and this is referred to as the inductive effect. What is the significance of this inductive effect? This effect decreases with distance as one goes from groups, that is electron attracting group, and the inductive effect decreases with the distance as one goes away from groups if in the case of electron attracting. Actually, if you are having more than 2 or 3 carbons in the chain, that C1 is having more electropositive character, that is del plus, and next comes C2, next comes C3, and another third carbon charge is negligible. And it could be an electron repulsion, that is if the atoms involved are less electronegative than carbon. That may be magnesium or aluminum, etc., or electron withdrawing groups, atoms with more electronegativity, that is oxygen, nitrogen, fluorine, etc., in the periodic table. And the weakening of the bonds between the heteroatoms may be oxygen, nitrogen, sulfur, and a hydrogen atom, is one of the outcomes of this inductive action. An electron withdrawing group weakens the OH bonds of an acid but increases the basicity of nitrogen atom, as it may be. And there are 2 types of inductive effect, minus I effect and plus I effect. And when the substituent attached to the end of the carbon chain is electron withdrawing, it may be a halogen, this effect is called as a negative induction effects. That is, we have to represent them as minus I effect. Using the inductive effect, we can predict the acidity and basicity of the compounds. As a generalization, it may be said that the electron withdrawing groups increases the acidity of the compound, and electron donating group decreases the acidity of the compound. If we take the conjugate base of an acid, for example, if you are taking an acid RCOOH, the conjugate base of the acid is RCOO minus if R is an electron withdrawing. Then the conjugate base is stabilized via the delocalization of the formed negative charge, that is the negative charge on the oxygen. If R had been an electron donating, then the conjugate base would have been destabilized because of their interelectronic repulsions. Plus I groups decreases the acidity or increases the basicity, vice versa, and minus groups increases the acidity of the compounds and decreases the basicity of the compounds. For example, if we take a very simple acid, formic acid, which is more acidic than acetic acid, this is due to plus I effect of the methyl group attached to the carboxylic group. See, we have represented the acids as 1 and 2, formic acid as 1 and acetic acid as 2. Here the 1 is more stable, more acidic than the 2. And if K is of an acid is high, it is a strong acid always. But if pK of an acid is high, it is said to be a weak acid. We all know that. The same logic is applied to bases also. Consider the acidity of mono, di and trichloroacetic acid. The presence of 3 chlorine atoms makes the oxygen, which is highly electron deficient, and thereby polarizing the OH bond the most. Therefore, the acidity order for the below compounds, it would be the third one is having more acidity when compared to the second one, which in turn is more acidic than the first one. And if we are having electron withdrawing groups, for example, in the box we are given with benzoic acid, which is substituted with the different groups like methyl, methoxy, chlorine and nitro group. Here when you are having electron withdrawing group, it increases the acidity, and we all know electron donating group decreases the acidity. And in this table, the methyl group attached to benzoic acid is having more acidity. Actually, the methyl group is a plus I effect, whereas the methoxy group is having a plus R group. So, methoxy group decreases the acidity more slightly than methyl. Therefore, the order of the acidity, it is D. D is having more acidity when compared to C, which in turn is having more acidity compared to E, A and B. So, D is nothing but nitrobenzoic acid, which is more acidic among the 5 acids when compared to benzoic acid, chlorobenzoic acid, methoxybenzoic acid and methylbenzoic acid. This is the topmost. Next comes the acidity of organic and unsaturated compounds. The acidity of an organic compound, that is nothing but removal of a proton, and we can from that we can check the stability of the conjugate base so far. More the stability of the conjugate base, the stronger will be the acid. And in the box we are having 3 different alkanes, alkenes and alkynes. The acidity among the unsaturated compound, check the hybridization of the carbon involved. When you take the first case, the carbon is in the sp hybridization state, whereas in the ethylene it is in sp2 hybridized and in ethane it is sp3 hybridized. The more the S character of the carbon, the more its electronegativity and hence more the acidity. Therefore, the most acidic amongst them is alkynes. Alkynes, next comes alkenes, then comes alkanes. And we can illustrate this using the following some more examples. Already we have discussed the acidity and basicity, that is here we are taking again the benzoic acid and substituting with different hydroxyl groups at ortho positions, meta and para position. That is methyl group is a plus I group, whereas methoxy group is a minus I group. So, here the order is the fourth one is having more acidity when compared to the third and second one. Next illustration, we are taking bases, different bases we are having in the list 1, 2, 3 and 4. First one is a saturated heterocyclic compound, second one is an unsaturated one and aromatic, and third one is also a saturated base which is having a heteroatom of oxygen as in its head, and the fourth one is pyrrole. Among the 4, first one is more basic when compared to the second, third and fourth. The next in the order there comes third one, okay, which is more basic when compared to the second and fourth. Saturated bases are having more basicity when compared to the unsaturated one, that is pyridine and pyrrole. So, like that the inductive effect plays a vital role in deciding the acidity and basicity of the aromatic and aliphatic compounds. Next one is the electromeric effect. It is a very simple topic. That inductive effect refers to the phenomena wherein a permanent dipole arises in the molecule due to unequal sharing of the bonding electrons in the molecule. And this effect can arise in sigma bonds, whereas the electromeric effect can only arise in pi bonds. Actually, it is an instantaneous formation of a dipole within the molecule of an organic compound, and this is shared by the pi electron pairs among the bonds. This effect is a temporary effect that remains as long as the attacking reagent is present when exposed to the another compound. And we are having 2 different effects, plus E effect and minus E effect. This effect occurs, plus E occurs when the electron pair of the pi bond is moved towards the attacking reagents. We can see it in the box. When you are taking ethylene and it is subjected to the reaction with an acid H plus, we will have occurring of the plus and small del plus and minus charges in the intermediate, followed by the formation of a carbocation. The attacking reagent attaches itself to the atom which obtained an electron pair in the transfer. So, plus E effect is observed when the attacking reagent is an electrophile and the pi electrons are transferred towards the positively charged atom. And a minus I effect, this effect occurs when an electron pair of a pi bond is moved away from the attacking reagent. That is, here we can notice when a cyanide ion comes in between the carbonyl group, when it attacks the carbon, automatically the carbon oxygen bond is polarized. So, minus E effect is generally observed when attacking reagent is a molecule, nucleophile, and the pi electrons are transferred to the atom, which the attacking reagent will not bond with. Okay. So, minus A effect occurs, there will be addition of nucleophiles. All the nucleophilic substitution reactions involves by this minus A effect. Thanks for watching. Thank you.